In our study, we asked the participants to perform exercise before breakfast, and our breakfast was a carbohydrate drink. And I'll mention why we chose a drink in a second. And we showed that if you exercise before breakfast, so fasted, our measure of insulin sensitivity was increased relative to when the same exercise was performed after breakfast. So the same pattern, performing exercise in the fasted state led to greater benefits for insulin sensitivity. And in our study, the carbohydrate dose was lower. It was much more representative of breakfast consumed in developed countries in terms of the dosage, and there was no extra carbohydrate during exercise. And the 6-week intervention, as I mentioned earlier, it was 50-minute sessions 3 times a week. So it adhered to current physical activity guidelines, and we were recruiting the overweight or obese cohort.
Terrific.
Yeah, it was a very exciting finding, and it was nice to see that it kind of matched onto some of that earlier findings. And it kind of got us thinking about why this might occur, and I think that's always important in science, is to kind of delve into the mechanisms, and that's what we wanted to do with this study, which is why we took those muscle samples. So I can tap into a little bit of that if you'd like.
Absolutely, yeah. Let's dive into that.
So I think to understand some of the differences between exercise and the fasted or the carbohydrate fed state, it's important to first think just about adaptations to exercise more generally. So apologies if this is recapping some of the basics for your listeners, but I think it's always useful to cover those basics before we talk about more specifics.
100%.
So the beneficial effects of exercise for health can be attributed to 2 main effects. So firstly, exercise increases our energy expenditure and acts as a potent acute stimulus for increasing muscle glucose and fat uptake. And that's basically to satisfy the energy demands of the exercise. So if we think of blood sugar control, each bout of exercise activates pathways in exercising muscle, which move the glucose transporter, which is a protein called GLUT4, to the plasma membrane to basically allow sugar to move from the blood into the muscle. And this is largely due to the activation of a really important protein called AMP activated protein kinase, AMPK. Mm-hmm. And this triggers some downstream proteins important in that cascade. And so we have this acute effect, but secondly, regular exercise not only increases the amount of time that we spend in this acute phase, but it also induces some long-term adaptations across many tissues that are also important for metabolic health. One example is each bout of exercise produces a short burst in gene expression of different key proteins, one of which is a protein called PGC1 alpha. And with subsequent bouts of exercise, if you keep the intensity the same, the magnitude of these bursts in gene expression might be diminished, but you get a build-up in the protein content of different proteins, for example, PGC1 alpha. And what will happen then is that will trigger some downstream adaptations, for example, changes in protein content of mitochondrial proteins. And I kind of mentioned it earlier, but of the molecular mechanisms that are important in exercise adaptation, one of the really key proteins is AMPK, which is this fuel sensing enzyme.
Yeah, I was going to say it's important for listeners to sort of understand that idea of being a sensor and being able to, the body's way of being able to appreciate whether there's additional fuels on board or not, and that these get released, and then from there we're getting changes in terms of what fuels are going to be oxidized for a fuel source, right?
Yeah, and it's important. It's one of the things that actually I love about physiology and why I got involved with studying and researching it. Is just how and the more you study, the more you realize that the human body is very, very intricate and it has all these systems in place. For example, if we talk about AMPK, it's a fuel sensing enzyme. It alters metabolism during and post exercise. For example, it increases muscle glucose or sugar uptake and glycogen synthesis by activation of a protein called AS160, and also increases lipid oxidation by a different protein called ACC. So all these different pathways going on, and you have different proteins triggering different pathways, and in a manner that's kind of sensitive to, in our conversation, the nutrient status as well. With endurance type exercise, which again, this is what we're talking about here, running and cycling, you're always going to be burning a mixture of carbohydrates and fat as a fuel. And since at least 1920, there was a nice study by Croft and Linhard, with the first authors in 1920. We have known that meal timing, so when you eat in relation to exercise, alters metabolism. With running and cycling exercise, in the fasted state, there is an increase in fat oxidation and a decrease in carbohydrate oxidation. So when we eat breakfast prior to exercise, you get this increase in carbohydrate oxidation, and that's coming from an increase in blood glucose, but also muscle glycogen. Some studies have shown a muscle glycogen sparing effect with carbohydrate ingestion before and during exercise, but with modest doses of carbohydrate, which is what we're talking about here, that doesn't always seem to be the case. And so for clarity, when I'm talking here, I'm mainly referring to endurance type exercise at around about 40 to 60% VO2 max. Because as you increase the intensity of exercise beyond that, into what we'd start talking high intensity exercise, you start to increasingly utilize carbohydrate as the fuel, irrespective of whether the exercise is in the fed or fasted state. And again, some great researchers in this area, Bergman and Brooks, had a study, I think it was in the Journal of Applied Physiology, that demonstrated that really nicely.
Yeah, I mean, this is such a fascinating area because, again, this idea of fitness level is one that's, we clients, oftentimes we always want to think of ourselves as athletes, and of course elite athletes are a different level than even recreational elite athletes. And when we talk about the fuels that need to go into, whether it's training nutrition or race day nutrition, it can be troublesome for recreational clients because they want to be fueling with, let's say, more carbohydrate to be able to elicit some of these gains. Yet, if we talk about body composition, they're not seeing some of these, reductions in body weight or even improvements in some of the metabolic profiles there. So can you touch on your experience with, working on the elite side, working with the general population? Are there some general recommendations or heuristics that you might give folks who are, trying to lose 20 or 30 pounds versus those who are pushing more at the elite level and need to really fuel those training sessions?
Yeah, I think you kind of hit the nail on the head right at the very start when you said context is key, and that's what we're talking about here. So I think the two paradigms are very different. So for weight loss and for improvements in health, I think we kind of touch at the very start that energy balance is very important. And there's some nice work, I think done by Susan Jebb, has looked at different, for example, different diets, so low carbohydrate, high carbohydrate, low fat, and the key seems to be energy balance. So if you can maintain a diet and maintain an energy deficit, weight loss will come in the long term. And improvements in health will also come. In terms of performance, I mentioned I'd done some work at the Peak Center for Human Performance in Canada. So I worked a little bit with, in that context, it was with aspiring ice hockey athletes, but also some endurance athletes. And again, I think it's context. So if we're talking about long distance or high intensity performance, then certainly your fueling would be different to if you're going out for a 30 to 40 minute jog and your aim is just to recreationally run or cycle to improve your health. And there, I think we can start thinking about the demands of each session, which I think is the key really to knowing and to having an awareness of if your session is going to be greater than 2 hours, you might start seeing muscle glycogen depletion. So it's important to think about carbohydrate fueling. If the session is going to be high intensity, again, you might want to think about some carbohydrate fueling. But if you're just going for a run or a cycle and you're trying to improve your health, then glycogen depletion at moderate intensity exercise, where you might get muscle glycogen depletion leading to fatigue. That's not going to happen for a couple of hours. So your body can perform in this moderate intensity zone in the fasted state. So I'll kind of touch in a second here. You might get some enhanced adaptations from performing that session in a fasted state.